Hi guys, welcome back to my channel Mr. Electron, and this what you see is a car alternator. Not just any car alternator, it's a BMW alternator with the current value of up to 180 amperes. That is why it is so special. And how I know that, I'll show you on its label. So guys, here as you can see that it's the value alternator, and it's also printed BMW 14V meaning volts and 180 A meaning amps. So it is 14 volts, 180 amperes. Now guys, this alternator stopped working. So to be sure, we will have to look into it. Well guys, this one seems like a perfect fit. Yeah, it's an 8 mm. Okay, got this piece out. Here you can see this saying B positive, which is the main output positive terminal of this alternator. Well, the brushes seem fine. I will give you a close-up. That's the rotor slip rings, and if you look closely, you will see the brushes. Okay, so guys, it's time to do some winding check. You see this and these three terminals. These are the wires coming out from this winding, copper winding, which is the armature winding. Okay. So let's check the resistances. Oh, the resistance is quite low. It is around 0.2 ohms. That's pretty low. Let's go for the other one. Yeah, this one also 0.2 ohms. Now comes the far ones, again 0.2 ohms. So yeah, the alternator is working fine for the armature at least. Now that's left is the rectifier. Well guys, now comes the part of finding the fault in the alternator, if there is or if there is not. So first we are going to do the self-excitation testing. Well guys, I'm also going to measure the current of this high current motor, 1.5 HP. Let's see how much it draws. Okay, so yeah, let's start the setup. You can see that the setup has started, and if we measure the current that this motor is drawing, okay, it is drawing 0.19 amps at around 70 volts. That's pretty efficient. Well guys, this time I'm going to connect the multimeter terminals to check if it generates some voltage and if it is getting self-excited. Since entire body of the alternator is a negative, so I'm going to connect it to the body, of course. Okay, so turning it on. Well guys, here as you can see that it is generating around 0.6 volts DC. So all I have to do is increase the RPM of the alternator and check if it can self-excite. You can see that the voltage on the multimeter is increasing. Pretty high volts, almost 1 volt, close to 1 volt. That is almost 1 volt. Yeah, it should get self-excited now. I don't know why isn't it getting self-excited. Let's go a little higher and see what happens. That is 1.7 volts. Still nothing. Turning it off. Well guys, finally I will have to take this part out. You see 1, 2, 3, these 3 screws. Let's open them. And let's see what the problem is. Nice and easy. Okay, cool. Well, the brushes as you can see are pretty good. Not a single problem. Well, this what you see, these are the slip rings for the rotor inside, or you can say the field winding. Let's check the field winding if it is working or not. So guys, for testing the field winding, I'm going to use this 15 volts 3 ampere supply, and let's see if there is a spark when I connect these to the slip rings, or touch it to the slip rings. That would be more appropriate. Yeah, there is spark, no doubt. So the field winding is fine. Let's make sure that there is no short circuit by ensuring the availability of good magnetic field. The field coil inside is really inductive, and as soon as I remove one terminal, it is going to give a good flyback. So there's still hope for it to be tested. Let's do it like this. Okay. Yeah, good magnetic field is being formed. I can feel it when I rotate the rotor. Yeah, the magnetic field is pretty good, which means the field winding is perfect and the slip rings are also fine, so there is no fault here. Well, let's open this case type thing and see what is inside. Maybe the fault is in here. You see here, it seems like the electric cable bus power system, and this entire circuit is filled with some kind of gel, you see. So guys, it seems like this three-phase rectifier is fine, but there is some problem with this voltage regulator. Maybe the diodes within this have stopped working or something like that. So anyways, there's always a solution or shortcut to situation like these, which is this. So let's remove it. This is going to be the direct positive terminal for this alternator. Okay, almost out. Okay, finally, as you can see, this one is the positive terminal for the brush. So I will have to give a solder over here and extend a wire or something like that. And about this, let's just cover it as it was before. Okay, yeah. So guys, here I'm going to use this red wire to add to the new brush slot or connection that we just opened. That's the positive one. That's done pretty good. So placing everything back as it was before. So you get a screwdriver thin as possible, and then push the brushes so that it creates space for the slip rings. Okay, first one done. Now the second one. Yeah, second one also done. Now all we gotta do is tighten up the screws.
Okay.
Yeah, it's running smooth. So guys, for confirmation, let's just check the resistance of the field winding or the rotor winding, for which the positive brush that is feeding the field winding is this one, and the negative is the body of the alternator. Yeah, the resistance is 9.4 ohms. So the coil is fine. Once again, the magnetic field check. Positive will be given to the red terminal and negative is the body, you see. And now we are in business. So let's connect it like this, and yeah, pretty good magnetic field has been established. And I remove it, it's free to run. Okay, look closely to the shaft, and it has become hard, you see. It is asking for a lot of power to operate, and when I remove it, then it will run really smooth. So guys, the final check will be completed by finding out if it is generating electricity or not. So yeah, this is a 55 watts bike headlamp bulb, 12 volts, 55 watts. So one terminal here I'm connecting to the positive. Okay, done. And this side will be connected, as I said, to any part of the alternator, since the body of the alternator is negative. Yeah, so that is also done. Now for feeding the rotor or field winding, again the negative will be connected to the body of the alternator, done, and positive to the brush. Okay, done, you see. And guys, here I'm feeding the field winding or the rotor winding with the laptop charger, 15 volts output. Okay, go. Wow, well, this is working pretty good. Again, and this time a little harder. Nice. So guys, here as you can see that I've turned off the lights once again. Okay, go. Guys, this is a large stepper motor, brand Vexta stepping motor, 5 phase with a DC current per phase of 2.8 amperes Oriental, made in Japan. So guys, now let's measure the voltage per phase of the stepper motor AC output. Okay, so I have pointed the meter towards 200 volts AC mode. Now let's connect the phase wires to the multimeter cables and turn it with hand. You can see the generated voltage is somewhere around 6 volts or 7 volts AC. Rope rotation voltage as high as 73 volts AC. Now let's try and glow this bulb with the stepper motor, and you can see that it is glowing brightly. Now what I'm going to do is use 5 of these bridge rectifiers, 35 amperes each, and connect them, all of them in parallel, to increase the overall output current generated by the stepper motor. Now guys, all the 5 phases of the stepper motor have been connected individually to the rectifiers, and the output of the rectifiers have been connected in parallel, and the final output is being connected right now. You see, yeah, the final output has been finally connected. Now guys, it's time to do the test with this bulb and see how bright it glows when all the phases are going to power it. So guys, the question for today is how many diodes will be used to make a 5-phase rectifier? Again, how many number of diodes will be used to make a 5-phase rectifier? Hi guys, in my previous video you saw me make a powerful high current 3-phase rectifier from two single phase rectifiers 35 amperes each. So today in this video I'm going to test this rectifier on a car alternator, okay, which you have already seen in one of my previous videos. Now guys, if you look closely on its back you will see that 3-phase rectifier is missing and the voltage regulator is also missing and the brush terminals are out, blue and red over here. And since there is no rectifier, only 3 wires, output wires are present, this one, this one, this one, which are the 3-phase. So to get a DC output we will need to add a rectifier. Let's move on to the connection of the rectifier. So take the rectifier and place it on any of the screws available. You see here there are 3 screws, this one, this one, this one. So I'm going to choose this one because the placing is just easier and no other reason. And you can see that I've also placed this sheet with this hole or bore in it, which is going to help me place it rigidly. So you see that it goes like this, and I have this nut. Now tighten up this one also, and now we have a pretty good physically stable 3-phase rectifier on the body of the alternator, just as another part that is attached to an alternator. So guys, let's first remove the final output wires, which are these two, the red and the black. Okay, they are getting in the way of me connecting the rectifier electrically to the alternator, and here they are removed. I'm going to connect it afterwards. So let's electrically connect all the 3 together, not together, to their respective pins with the help of the clips. So the first is the blue one attached to the first wire of 3-phase, second the black one. Okay, you see that's the black one, another AC. Done. Now all that is left is the last one, taking it from below, and we have the third one also connected. So guys, all the 3 wires from the rectifier, the 3-phase wires from this custom made rectifier, have been connected to the output wires from the armature winding of the car alternator, which were these 3, 1, 2 and 3. Okay, now comes the part of getting the output from the rectifier. This one is black. Okay, so negative connected, positive in process, and done. So guys, positive, negative both have been connected, and finally we have the 2 wires on which the entire generated output voltage and current will be available in the form of DC or direct current. Okay, let's place the alternator like this, and we have a robust setup over here, easy to operate. And yeah, this piece of the rectifier, it has a great quality that it can handle a surge current of up to 400 amperes and a continuous current of up to 50 amperes because of the 2 rectifiers, and one rectifier has a capability of only up to 35 amps. So let's test it without any further delay. Now guys, you might have already seen this laptop charger of mine. Now if you look closely you will see that it's rated at 12 volts and 5 amperes, which is what I'm going to feed this alternator with on its rotor winding. Although the current is not going to be exactly 5 amperes because the rotor winding does not need so much current for excitation. It excites even at 1 amps or 1.5 amps. Here are the 2 wires, positive for red and black for negative, which will be connected on these 2 wires. Black being the negative will be connected to the blue. First let's connect the red wire. Okay, red wire has been connected, you see. Now comes the black, but I will connect it afterwards. First I will have to connect a load on these 2 terminals or a meter, and then do some hand rotation and rope rotation. Here as you can see that I have this car headlamp bulb, 55 watts. So let's connect it to the 2 final output wires of the rectifier. Okay, as you can see that it has been connected. Now guys, let's wound the thread on the pulley of the alternator and then see how bright it glows. Okay, this much should be fine. One more turn. Okay, now keep watching the bulb over here. Oh, you see Now let's turn off the lights and see how good it is this time. This guy's finding thread once again. Although the pulley gets really tight when I pull it. If the pulley had been bigger, then the pulling part would be a little bit easier and the bulb would have glown even better. But let's do it now. Yeah, it is good this way also. Now guys, here as you can see that I have the multimeter, so let's point it towards DC voltage measurement mode. Okay, and this is the heat sink that I'm using as support. Okay, multimeter has been connected. Well guys, it seems that the multimeter should be closer and the alternator should be on the other side because it's not clear. Yeah, and now it is visible. Okay, so let's wound the thread and see how much voltage it indicates. Now guys, I am measuring the maximum voltage possible that this alternator is going to generate. Okay, and why am I doing that? Because I have removed the voltage regulator, or you can say that I have bypassed the voltage regulator, so the alternator is free to generate as much voltage as possible depending upon the RPM I give here. Okay, the voltage regulator limits the output voltage to 12.5 or maybe 13 volts, but there is no limit now. I have added separate rectifiers. Okay, so let's mount the thread and see what happens. Okay, so guys, keep watching the display screen here. Okay, go. As you saw, it was around 17.5 volts DC. Now guys, this is a very good multimeter with 600 amps current display and all, but there is one problem, is the super fast display. Okay, you see that I have to rotate and then it takes little time to display the exact voltage, which is not the case with this cheap one, although it does not have so many functions and easiness, but still its instantaneous time is really good. So let's disconnect this multimeter and switch it with the other one and then do the same test. Okay, so multimeter has been connected. Once again, winding the thread. Let's move it aside. Keep watching the display screen. Okay, go. You saw that it was somewhere around 19.5 volts. Now guys, we have already seen the voltage. Now let's point it towards the current measurement mode, 10 amperes. Okay, and move the wire pointer like this. Okay, keep watching the display screen guys. Okay, 7.5 amperes. That was pretty good. Although the pulley is very small, it was really hard for me to pull the thread, and 12 sevens 84, so the maximum power that I am producing over here is 84 watts. If we consider only 12 volts, then it is 84 watts. But if we consider 20 volts because of no voltage regulator, then this power is going to increase from 84 to 20 into 7.5. So 7 to the 14, 140 and like 0.5 extra. So you see that how removing the voltage regulator actually increases the overall output power of a car alternator. You can use a stable buck converter to reduce the output voltage from 20 to 12 volts, just as in solar panels, and you can get more power output from the same alternator. Let's give it one more try. Go. You saw 9.54 amperes, almost 10 amperes. That is the maximum capability of this multimeter to read. Otherwise, it is going to get damaged. I mean, the shunt resistance inside it. Now guys, I have this really big 250 watts bulb. Okay, you see 24 volts and 250 watts starlight. So let's connect this and see how bright it glows, or even if it is possible for this alternator to glow this just by hand rotation. Okay, so the bulb has been safely connected. Complete the thread winding part. Done. Okay, connection made. Okay, keep watching the bulb over here. Okay. Oh, it was really difficult. The tungsten filament is really thick. Yeah, and it is hot. Now guys, let's try it once again in full close up. You see? Okay. Yeah, that's the max I can do. Now guys, here as you can see that I have connected a very powerful large DC motor, permanent magnet DC motor, to the car alternator with the help of this belt. Okay, and the rating of this DC motor is 1.5 HP, RPM 4000 volts, 187.5 amperes, and field permanent magnet. And you see that here I have this rectifier installed and no voltage regulator. And I want to see what is the maximum voltage I can achieve if I bypass the voltage regulator, meaning no voltage regulator at all. Okay, so let's connect the DC motor supply to this motor controller. Okay, so let's turn on the supply now. Okay, go. And now let's connect the final excitation terminal from the laptop charger. So guys, the output voltage, as you can see, is around 8 volts. Only 8 volts DC. Let's increase it by increasing the RPM of the DC motor, of course. You see, I've increased the speed of the DC motor. Voltage has increased to 9.46. Let's go more. We have reached around 12 volts and crossing almost 15 volts and close to 17 volts. Let's go even higher. 17.18 volts. You see that the voltage regulator fixes the output voltage of the alternator to around 13 volts, and we have gained around 18 volts more. 20 volts guys, 20 volts. Let's go more. 20 to 23 volts. A 12 volts alternator is producing 24 volts almost. And we are doing almost full here, and the belt can break at any time. Okay, let's reach 24 volts and see what happens. Here we are reaching 26 volts. So let's turn it off. That was seriously a great experiment, guys. So you see that if we bypass the voltage regulator, if we remove the voltage regulator from a car alternator, we can go to much higher volts than to what it is designed for. So guys, I hope you liked or enjoyed this video. Please hit like and don't forget to share and subscribe. See you in the next one with more wonderful videos related to alternators and DC motors. Okay, hit that subscribe button and bell icon. Bye.